All right, time to go to work in my Chevy. Hey, what do you think you're doing? What's up? Oh, Leo.
Oh, hello. Today we're going to be working on this 2016 Chevy Silverado. We're going to be taking care of it. We're not going to be cutting the cats off it. This has the 5.3 liter V8, and we're going to be looking at the catalytic converters. We're going to be looking at the data from the oxygen sensors. We're going to be checking rich and lean conditions. We're going to be hooking up a 5-gas analyzer to the exhaust and seeing what kind of exhaust emissions we get. So let's get right into that and get started on it. This truck is a V8, so the catalytic converters are off the sides of each cylinder. You can kind of see the oxygen sensor from here, but I'll show you better from down below. Here underneath the truck, you can see on the left over there the catalytic converter off bank 1. Right over here you can see the catalytic converter off bank 2. So we're going to be measuring our temps on bank 2. If you look up there a little bit, you can see the upstream sensor, and then right there is the downstream sensor. Same on that side. If you follow the exhaust back, there's the merge point, and if you continue back further, there is the rear catalytic converter right behind this piece of frame member right there. It's kind of hard to film this, but I can take the exhaust temp before. That is 66 degrees upstream of the front and 66 downstream of the front cat. And if we come to the rear cat, upstream of it we have 66 degrees again, and downstream of it we have also 66 degrees. So here's a graph of our measurements. I'll go ahead and explain beforehand. You have the engine here, front upstream and front downstream is on the front catalytic converter, and then behind upstream and behind downstream is on the rear catalytic converter. Here is before your upstream cat, here is after your upstream cat, here is before your downstream cat, here is after your downstream cat. So early on the front upstream cat was warmer, but then this one, the rear of it, exhaust of it ended up getting hotter because of the catalytic converter stuff going on inside. And then the rear catalytic converter stayed hotter early on throughout, and that kind of just continued. Further back in the exhaust stream, it cools off significantly. You can see it was not nearly as hot after as it was before. At 2,500 RPM here, this is in front of your front cat, this is behind your upstream cat, this is in front of your downstream cat, and this is behind your downstream cat. So you can see here that the exhaust of your before temps, the engine's already warmed up. So you can see that the exhaust from your front cat is almost always hotter than the inlet to it because of the chemical reaction that's going on inside. And then on the rear, it's not the case. What with it being so far back in the exhaust system, I believe that is why the temperatures going into it were higher than the temperatures coming out of it. That's not to say that's not hot, it's 350 degrees, but you can see inside the truck with the engine running at idle and with it warmed up here. Come over here and look at O2 sensor voltages. Unfortunately, it doesn't show us exactly what the sensors are reading, but and then short-term fuel trim, long-term fuel trim, relatively even, little lean maybe. And if we rev it up, hold it about 1,000 first, and I'll show you what I'm seeing. Tries to go a little leaner, and if I hold it about 2,000, still wants to go lean.
So now we have our fuel trims graphed here on our scan tool. So we have our short-term bank 1, that's going to be the blue graph or the blue line. We have short-term bank 2, which will be the green line. Then we have long-term bank 1, which is the red line. And we couldn't get bank 2, the long-term for bank 2, because this scan tool only allows 3 pits to be graphed at a time. So right now we can see the numbers right here. So right now it's 0, the negatives. So when it's negative, that means it's lean. When it's above 0, then that means it's running rich. So right now, Leo's over here with propane, and he's gonna put some propane through the intake, and we'll see what happens. So Leo, you go ahead. So you can see the short, yeah. So we can see the short term went down to about -8, -9. And when he stopped putting it in, it went to 0. So that means it's running lean. You see the graph where it spiked when it went down. So it went to -9. And the engine kind of bogged down a little bit. Now it ran rich a little bit to overcompensate. Alright, so now we're looking at the O2 sensors for bank 1 and 2. So sensor 1, that's going to be your blue. Sensor 2, it's going to be your red for bank 1. And bank 2, sensor 1 is green. So we can see here that it's going up and down between rich and lean. And when we put some propane in, go ahead. See it spikes down. And then it holds at the top a little bit. All right, you're good. So it spiked stayed up a little up there, and now it dips all the way down. So now it's running rich. When it goes up, that means it's lean. So when it goes down, it's rich and it's running rich, so it can compensate for how much fuel it lost. And now we can see that it's trying to go back to normal and trying to equalize, yeah.
So here we've got the 5-gas analyzer hooked up to the exhaust of the Silverado. And here's the data we've got. So CO2, right now. So O2 should be 0.7 to 1.5, more is better. That tells you if it's a lean mixture. So O2, we have 0.5, which is slightly rich of where it wants to be. Hydrocarbons should be 100 parts per million or less, which will show you if it's lean. 82, 83, that's a good reading. When we had it at 2,000 RPM, it was sitting right at like 3 to 4 parts per million. Carbon monoxide is an indicator of rich, so 1% or less is good. And right now we have 0.1, 0.9, 0.09. So that's pretty good. And then NOx, want it to be about 2,300, is hard to control. And then CO2 is a measure of efficiency. So CO2, we have 15.5 parts per million. No, sorry, that'd be percent, 15.5%. And CO, what was the other? Oh, NOx is right
Are you videoing?
Yes.
Miles was parked here! Miles was parked here!